Welcome to our webinar on tips for testing electronics. Thank you so much for being here. I'm Nick Erickson, your host for this webinar. Today I'm joined by Theresa Smith, a product manager within our static testing division. She oversees many products, including the Torsion Add-On and automated XY stage that are commonly used for testing electronics. In previous roles, Theresa worked within our dynamic and fatigue and impact testing groups, giving her a wide range of experience and insight into the unique testing challenges our electronics customers face. We're also joined by Charlie Pryor, an applications engineer here at Instron. Charlie works closely with several of our customers in the electronics industry, working to identify new or more efficient testing setups. He's also helped develop a number of new testing solutions for batteries, something that is coming up more frequently as the automotive industry continues to shift more towards electric vehicles. We expect the presentation should take around 40 minutes, and then we'll have some time for questions. And I do encourage you to submit any questions you might have here as we go along, and we'll just plan to address these at the end. So with that said, I'll turn things over to Theresa to get us started.
Thanks for the introduction, Nick. Hello, everyone. Good afternoon. As Nick said, my name is Theresa Smith, and I'm a product manager in the Low Force Applications Group. Thank you for joining me today for the webinar on electronics testing. Today's discussion will focus on three areas. We're going to begin with automation and how that can help you to increase your lab efficiency, allowing you to make better use of your resources. Then we'll look at some interesting accessories that many of our customers just aren't aware of. Universal testing systems have so many uses, but a lot of times people just aren't aware of how much information about their products they can gather from their test systems by adding new accessories. And finally, we'll review some tips that you can use to ensure your test results are repeatable. One thing we hear from Instron customers across all industries is that they're always looking for ways to improve lab efficiency. This certainly holds true in the electronics field as well. Automated systems are one way that customers can improve their lab efficiency. A semi-automated solution like this motorized XY stage has a great deal of flexibility, and it can be used for a lot of different applications in the electronics industry. We say semi-automated because this isn't a fully automated system, but it's a really nice solution for a wide range of applications where maybe you don't have the need or the space for a fully automated system. Before I talk about the benefits of an XY system, I'm going to share a video of this system running several tests. I always find that seeing the system running helps to understand what the system is and how it functions and what types of applications it's useful for. So give me 1 second here so I can pull up the video. XY stages are often used to measure tactility on keyboards. These results can help the product design teams achieve the feel that consumers want in their products. We refer to the collection of test points here that you see the test going through as a sequence. This sequence is created and stored in a software test method. In this video here, we see that mini USB keyboard under test. In this case, a small keyless drill chuck is being used to hold the test probe. And the particular keys that are being tested, the WA, SD, and space keys, those are all set up and stored in the software sequence. As you can see, the stage moves automatically between each key, and then after the test is complete, it moves the stage into position. So now it's really easy for the user to remove the tested component and set up the next one. XY stages are also commonly used to test screens. This one shows a compressive load that's being applied at 9 different locations around the screen. And this is to simulate loads that it might see in use when somebody is tapping at the screen to take different actions. And this last one shows an integrated circuit test. The materials that are used to manufacture integrated circuits, they're rapidly evolving. So here it's being tested in a diamond pattern. The chip is loaded in the center of and then at 3 points around the edge. At each point, it's loaded with a compressive load of 120 newtons, that helps measure component deflection and stiffness, and the corresponding voltage is also measured and stored. So the stiffness and voltage data can be used to compare various chips and to qualify new materials and forms for electronics packages. So there's really a wide range of tension, compression, and bend tests that can be set up on an XY system as long as the proper fixturing is used. The addition of an XY stage to a test system can bring several benefits to the lab. The first is throughput. It enables customers to increase throughput and thus reduce the overall test time. This means that operators in the lab can work through their testing backlogs more quickly and provide faster turnaround on data that might be used for an R&D project or might be needed for production release of a product. Once the operator sets up the sample and starts the test, they're able to walk away from the system. This allows them to use their time more efficiently because they can work on other value-added tasks, such as completing test reports. They also don't lose time testing when they attend to other functions, such as attending meetings or even just stepping away from the system to have lunch. And repeatability is the third benefit. The stage can position the specimens or components with greater repeatability, which reduces the operator influence on the test results. That operator influence can be amplified when you have multiple systems that are being used for tests, and they're run by multiple operators who have different levels of experience. And maybe these systems and operators are even spread out over multiple labs, and that just adds to the challenge of obtaining repeatable results. We'll talk about each more of these in a little bit more detail. As far as the time it takes to run the test itself, there's nothing that really can be done to shorten that amount of time. Typically, the test speed is set based on an industry standard or internal guidelines, and there's no way to speed up the actual test part of it without compromising results. But there are other areas of the testing process where you can save time. So properly loading a new specimen to be tested, ensuring that it's set up properly in the fixtures and that it's well aligned, that can take a significant amount of time. Even removing tested specimens can take a good bit of time. This is where an automated system really can have an impact when it comes to increasing lab throughput. So here's some data that compares the time it took me to run 50 compression tests on the spring. So I ran 50 tests manually, and it took a little over 15 minutes. These tests I ran immediately one after the others, so there were no distractions, no breaks. But in reality, operators usually have interruptions throughout the day. They have to step away from the machines to go to meetings, or they might have a conversation with a colleague. So these particular tests, I was able to run them more quickly than you might expect in a typical day in the lab. When using the XY system, these 50 tests were completed in about 8.5 minutes. The XY system made it possible to test 46% more specimens in that same time period. And this extra time can really make a difference when it comes to introducing a new device into a competitive consumer product market. It can make an impact to engineering project deadlines, even to shipping new product to get the okay from a quality check to go ahead and ship those new products. To further improve throughput, customers often will have multiple test fixtures for use with their XY systems. While the system is testing one group of specimens, the user can prepare the next group. And then once the first test ends, it's very quick and easy to load up the next batch. And then in this way, they can minimize downtime that might occur between tests. So as we just saw, when you're looking at those 50 spring tests, the XY generated an improvement in lab throughput by 46% over the course of an 8.5-hour shift. In that same 8-hour shift, the operator would actually gain back 3.5 hours of time. That's because when the XY system is in use, the operator doesn't have to stand in front of the system during all of the testing. When you test manually, the user has to be there and ready to remove a tested specimen and then load the next specimen up to keep the test flow going. But when you use an automated system, they can leave it unattended and they can go and attend to other tasks. They can go analyze test data, they can write and distribute test reports, they can even get the next batch of specimens ready for testing. There are many factors that impact repeatability. In fact, as we mentioned during the goals, we have a section on repeatability later in this webinar. But one important benefit of an XY system is that it provides repeatable test locations from sample to sample, which ensures that the data being generated is comparable. The integrated chips that you see here, each chip has a compressive load applied at 5 points. So as I mentioned during the video, 1 point in the center, and then 4 spots around the edge. The XY system allows the user to create the location of those points and store them in a test method so that the user can be confident that those test locations are consistent from specimen to specimen. The fixture design also contributes to improve repeatability for this test. You can see it holds 5 structures of different sizes. If you were testing these tiny components manually, it would be very difficult to load those into the system and position them consistently to make sure that on each specimen, the same 5 locations are being tested. And then you'd have to manually adjust for each of those 5 test points. Making sure that all those chips are tested at consistent locations with a manual system, it requires a great deal of attention and time. This slows up the testing process and it increases the variability in the test data because operator experience here can have a great impact. An XY system with a well-designed fixture, such as this fixture shown here, addresses the challenges around specimen placement and consistency of test locations. This reduces the influence of operator experience on repeatability. These electronic devices are all used on a daily basis. We all use our phones, tablets, screens, keyboards, and so it's really important to perform testing to make sure that the device can stand up to regular use and misuse. The user experience is really critical to product success also. So devices are tested to characterize the tactility of buttons and touch surfaces and switches. A button that's too stiff may be difficult for the customer to use, given the higher force that's required to operate it. On the other hand, if you have a button or a touch surface that's overly sensitive, that's not ideal either. A relatively small force might be enough to inadvertently engage the device. All the devices seen here, including wearable sensors and remote controls, these are all tested to help engineers design products that make the user experience one that can help turn consumers into loyal customers. The XY system can help make testing faster and more repeatable for all of these devices. It's not only the end product that needs testing, the internal components of the device need to be tested as well to ensure that they can handle possible loads they'll be subjected to. When the end product is bent or twisted, or when it gets bounced around during storage or transportation, there's always that risk that the internal components could loosen or become damaged. So those need to be tested as well. So here, in addition to that multi-point compression test on the integrated circuit that we've looked at already, there's also a pin pull test on a board. The XY system can really help reduce operator influence on any device, but that certainly becomes more critical when you're handling small components such as these. There are a lot of electronics used in our cars and other vehicles that lend themselves really well to testing with an XY system. These include items such as the key fob buttons, as well as the touchscreens and control panels in the center console. Battery testing is also a popular application for batteries, both in personal devices and in automotive industries. This indentation test on a battery requires loading the battery at multiple points. The XY makes it easy to move between those test locations. And even in addition to components and parts and devices, you also have just the more general materials testing, The XY system can perform tension, compression, or bend testing on small specimens that might be used for QC testing, or even to characterize new materials that are being developed. Using an automated XY stage for any of these applications would provide all the benefits that we've been discussing: throughput, efficiency, and repeatability. One final thing to mention about the XY stage is that while it offers a lot of flexibility and benefits, it can still be used to run tests manually. This can be done with the addition of a simple base adapter. You can see on here a gray base adapter, and that replicates that Type O coupling that comes with the system itself. So you can use that, and with your any grips or compression platens or bend fixtures that you have that you use on your regular load frame, you can simply use this Type O coupling with those as well. And that's a great option in case you might use your XY system for some applications, but there might be other testing that you have that's lower volume, so it just doesn't make sense to run it with an XY system, or perhaps you just haven't had the time to develop the fixtures needed to run that particular test on the XY stage. You still have that option to use the system with manual load string, and you don't have to remove the XY stage in order to do that. Universal systems are really flexible, and they can be used for a wide range of tests in many different industries. You are all familiar with certainly the most popular accessories such as grips and bend fixtures, but I'd like to cover some accessories that you may not be familiar with that could help you learn more about your products. The devices that we use every day, they can be subjected to many extreme forces. Some are mechanical, some are temperature, but generally speaking, you really want to run more than just basic tension or compression tests on a product. You really can do more to truly understand how your product is used and what stresses they're subjected to during use or even during transportation. There are a range of accessories that can help simulate what the product undergoes when in use. This knowledge can help the design team to make a more durable product with a better user experience for the consumer. Electronics devices are regularly subjected to torsional forces. So this might be a part of its regular use, such as somebody getting a little overexcited in an intense video game and twisting that game console in their hands. It could also be something unintentional where you throw your device into a bag and it ends up being twisted or bent around other items. So device design needs to take this into consideration because these are things that people do with their products on a regular basis. And it's important to ensure that products can withstand those day-to-day stresses that consumers sometimes even unknowingly subject their devices to. Consumers expect that their devices aren't going to break or malfunction because of what they consider to be regular handling. When the device is twisted, the internal components, such as the flexible screen, that gets twisted as well. So it's important to understand how these torsional loads affect the product. Are the right components being used? Is the assembly process working well? Are adhesives or the welding techniques that are being used in assembly sufficient? Torsion testing can be an important part of simulating those real-life use conditions, and this can help engineers verify design, confirm that their product meets their quality requirements, and validate that suitable manufacturing techniques are being used. There are a few different options for torsion testing. Some systems are dedicated to torsion only, such as the MT microtorsion seen here. Some systems, like the Electropulse, are built for combined axial and torsion loading, even combined fatigue loading. Others, like the Torsion Add-On, make it possible to add torsion to a new load frame or even to an existing axial system that's already in the lab. And it can be used on any size system from a single column to a floor model. This system has a great deal of flexibility. It can be used for a number of applications. I have a video here to show a couple of applications just to give you an idea of what torsion testing is for those of you that are unfamiliar. This is a cyclic torsion test being performed on a flexible display. It simulates the display being twisted back and forth repeatedly, as it might during manufacturing or shipping, or once it's installed in the device. This isn't a maximum torsional strength test, but rather it tests the durability of the display. Torsion is also common on any type of cable or wire that might be twisted during use. This is a multi-rotation test. Again, it's a durability test to quantify how many times that cable can be twisted before failure occurs. These videos show torsion testing on components, but it's also an important test for full devices. Handheld devices like your phone, it might not require any torsional loading for use, but the reality is that consumers are going to twist it and flex their devices. And again, they don't expect that to affect the device's functionality. The addition of a torsion add-on brings several benefits to a lab. The first is it gives the ability to simulate product use. The best way to evaluate a device is to test it in a manner that really mimics how the consumer uses that device. When you simulate product use, it allows you to better understand how your device functions when it's used in real life. That in turn allows you to improve and validate the design. Adding torsion can also help reduce time to market. It gives you, when you have the ability to perform both axial and torsion testing on one system, that saves time. You don't have to move specimens and load strings between different systems. You don't have to develop different sets of test fixtures for multiple systems. All the data is gathered on one machine. And this is also great because the user doesn't have to pull together data from multiple systems and then try to correlate that data. Blue Hill Universal has fully integrated torsion control. It has torsion calculations. So there's really minimal additional training needed for operators to run axial torsion tests. And finally, improving lab efficiency. Lab space is at a premium. Adding a dedicated standalone torsion or axial torsion system can take up a substantial amount of space. When you add the torsion add-on to an axial system, it doesn't change the system's footprint, so that capability can be added with no impact on lab space. Torsion loads are regularly applied to the devices we use on a daily basis. Devices like our phones or tablets or remotes. We twist them in our hands, we sit on them, we toss them around. Internal components such as flexible displays or populated printed circuit boards might also be affected by these torsion loads, and so testing is important. And cables, as we saw, can easily be twisted as they're routed around or through equipment. Adding torsion is one way to expand your system's test capabilities. There are other ways also, so we'll move on from torsion now to look at some of those. We've seen some photos and videos of testing performed on various buttons. Using mechanical testing to quantify the durability of the buttons and the tactility of the buttons, that's one aspect of testing, but these devices also have electrical contacts. It's important to determine how those contacts hold up after repeated use. That measurement, that voltage measurement, can be incorporated into a mechanical test, as we'll see in this video. Here you see the spacebar on a keyboard being tested in 3 spots. The software screen displays the load curve. You can see it there in the brighter red. When the key is pressed, the resulting contact allows a signal. We also have a power source connected to this keyboard. And so when you press the space key, that resulting contact outputs a signal through an external amplifier or signal conditioner. And then that output from that signal conditioner, which has a 10-volt output, is fed into the frame's transducer channel through a standard cable. And you can see that signal plotted here in the dark red alongside the load data. When you look at these 2 plots, you can see at what point during the key press that electrical connection is completed to make the intended action, which in this case is to insert a space. That voltage data can be stored in the data file and displayed in the results table, along with calculated results such as the click ratio. Many products have requirements to be tested at non-ambient temperatures to simulate environmental changes that might occur during use or transportation or storage. A typical configuration for testing at non-ambient temperatures is to put the specimen and fixtures into an environmental chamber, such as the ones shown here. The temperature can be set using the built-in controller or through the software. Using the software is nice because it allows the temperature to be changed during the test if necessary. Chambers have heating and cooling systems that are optimized for thermal stability and that reduce thermal gradients within the chamber. This suits most applications that have requirements for testing at non-ambient temperatures, but in some applications, it's important to have temperature measurement directly at the specimen. In those cases, a thermocouple can be attached to the specimen itself for a more accurate temperature reading. So here we have a thermocouple attached to a battery. That thermocouple signal wire is then fed through a signal conditioner, and then into a transducer channel in the frame. Then the temperature data can be acquired and stored in the software alongside other test data, such as load and displacement. When you have direct specimen temperature measurement like this, it eliminates the impact of other factors, things like thermal sink from fixtures that could potentially affect temperature at the specimen when you're testing within a chamber. This allows users to get more consistent results if they're performing tests on systems that have different chambers, and maybe those chambers have different specifications, different heating time, the thermal gradients may be inconsistent, and so it might be difficult to, based on the temperature controller itself, it might be difficult to get consistent temperature at the specimen. So if you're able to test at the specimen itself, you're able to really understand and ensure that all your specimens are being tested at the same temperature. This becomes particularly important if you have temperature specimen components or materials. We've looked at just a few of the ways to increase your system's capabilities. There are others, many others. So if you have an interest in a particular area that we don't cover today, please reach out and I'd be happy to provide you some information. But for now, we're going to move on to one of the most important requirements when it comes to mechanical testing, which is repeatability. In your labs, you might have multiple users performing tests on multiple frames during multiple shifts. Many companies nowadays have test labs that are spread throughout multiple sites around the world. Data from all these different labs is often compared, and it's expected that those results for a given product are going to be the same, regardless of where the testing was performed or who did the testing. When there's differences in that data, it's necessary to understand the root cause. This can really be a challenge as there's so many factors that can affect test results. It might be due to the lab environment, because heat and humidity affect load readings. Maybe the test systems are from different manufacturers or different vintages. It could be that the test methods or load strings being used are different. It might even come down to different operators having different levels of training and experience. Getting to the root cause of those differences can be really a challenge. So it's helpful when there's features that can be used to minimize the differences from system to system when it's possible. One way to do this is to share test methods among frames. The ability to share test methods between different frames and different labs across, around the world, this is a great way to ensure that the tests are being run with the same parameters. Your specimen information, test parameters, calculations, results, even the test report are all set up and stored in the test method. So sharing makes it easy because the labs don't have to, these can be shared easily between labs, and the lab doesn't have to either create a test method from scratch or create a test method based off of a document that outlines the test procedure. Test methods, you can even set them up to be prompted so that operators get clear instructions for each step. And this all helps to make sure that there's consistency between how the testing is run, regardless of where the labs are. Setting up the calculations properly is also a really crucial part of the test method. Of course, each site and each system has to be using the same calculations and calculating all the results in the same way. So Blue Hill Universal has a large calculation library to help make testing and data analysis quicker. But this, especially for electronics, there is a special button calculation, which was added given the popularity of button testing within the electronics industries. These calculations determine the operating touch and return forces, along with the click ratio. These calculations basically can help the user quantify the tactile feel of a button. For example, a button with a high click ratio will feel a lot firmer, while a low click ratio will indicate that the button has a much softer feel. These calculations provide information that help the product design team select the best button for a given application. Even when sharing test methods, using different fixtures or setting the test frames up incorrectly can cause differences in data, especially in labs where load strings are changed around often. There's really a risk that a user might install different fixtures for a particular test than was previously used. Customers, we always have creative customers with good ideas, and they've come up with their own ways to address this, such as you can see labels here, where they've added manual labels to the system column, and they use these to remind users to put the crosshead into a specific position before they start the test, or even not to move the crosshead past a certain point to make sure that they don't damage something. This can work for systems within a lab if they're all labeled correctly and the labels are followed consistently, which means that the users need to understand the purpose of the labels and follow them. But it leaves a lot of room for error. And of course, this doesn't transfer to systems in other labs. In this case, a feature such as auto positioning ensures consistent setup as it helps guide operators through system configuration, making sure that they get repeatable use. It does this by remembering the initial crosshead position for each test. So the user doesn't need to remember when they hit start on the test, the crosshead will automatically move to the proper starting location and balances displacement. This ensures that all tests are started at the same location every time, which improves repeatability in the lab. This feature also allows fixture information, installation notes, and even photos to be stored in the test method. The operator can reference this when setting up a test to make sure that they're using the correct load string. Once again, the ability to share test methods helps achieve consistent test results across labs. You may have a lab that developed this particular test setup, including the load string, and once they have the test method fully developed and tested and ready for use, they can release this to other labs at the company. And this helps ensure that every lab is using all the same information and running tests as closely together as possible. I'm going to hand this over to my colleague, Charlie Pryor, one of our wonderful applications engineers with a specialty in electronics, and he will take over for these last few slides.
All right, thanks, Teresa. Yeah, so a few more slides that I'll go through, and then we'll get to some questions. So if any questions have come up along the way, please feel free to continue submitting those. So here, talking on the lines of throughput and repeatability, I think something that's always worth pointing out is pneumatic gripping. So when we're talking about tensile testing, pneumatic side action grips, both dual acting and single acting side action grips, are almost always going to be recommended for general testing and for high volume, especially when an automated or semi-automated system is not available. This could mean, if like the XY stage that Theresa was talking about before, if it can't be automated with that, or one of our full automation systems. Some of the biggest benefits behind here with pneumatic grips is the repeatable and the constant gripping pressure. So not only is it going to be able to provide the same gripping pressure every time, but one thing that's always important to point out is it will provide constant pressure. So if you're sending 90 psi to the grips, but the specimen starts to thin or extrude through the grips, it's really important to have a constant gripping pressure that can actually adapt to that, so that your specimen still will not slip out. Another thing that's really beneficial is our software control and integration for pneumatic grips. So this isn't, just related to, smaller testing, but it could be for materials as well. But you can go into the software and you can actually control how much pressure you're going to be sending to the grips. And the software will also be monitoring the pressure throughout your test. So it'll know if your pressure to your grips varies. Additionally, one of the other big benefits behind some of our smaller pneumatic grips that will be used for electronics testing is they always close to the same position. So you're always going to ensure you have proper load string alignment there. You're not going to have an offset of your specimen. And then another thing that can be very useful for high throughput, production level, or just R&D in general, but is our optional open and close control valve. So if you look at the picture to the left here, these are our 250 Newton pneumatic side action grips. It has a toggle. If you look at the bottom grip, you can see it pretty obviously in the front that goes left to right. Yeah, Teresa's showing it right there. So that toggle can be really beneficial for placing specimens in the grips, especially when you're a very small specimen and you need to be very careful about where you're putting it in there. You can kind of have one hand ready to close it right as you get it in position. And that can be very useful. And so these are ways of kind of helping increase your repeatability. I know Theresa talked about some various aspects of testing parameters that can really affect lab variability, operator availability. So this is just one of those ways. Another thing is specimen alignment. So not just the jaw face alignment, but the specimen alignment itself. Theresa, I think we have a video here if you want to pull that up real quick.
Charlie, you might be muted.
Yep. Yeah, so this video is showing one of our specimen centering devices on our pneumatic side action grips. It shows an example of how it can be used. So this is, for a plastic material, but these specimen centering devices can also be used for much smaller and more delicate materials, which are more common in the electronics industry these days. And I'll talk to that more in a second after the video. So within the electronics industry, we've been seeing a need for materials becoming thinner, lighter, safer, primarily microelectronics, for electric vehicles, for battery testing. There's a constant need for these smaller materials and to maintain the same safety parameters that are there right now, if not maybe even improving that. And so with that always can come some testing difficulties as your material becomes more delicate and harder to grip and more fragile as as an operator might be handling it. So it is essential to have a repeatable testing solution when you're testing these materials or components themselves. So Instron's developed specimen centering devices that can provide an easily adjustable solution here, and it can help improve that testing repeatability. The benefit behind these is it can allow for each specimen to be placed in the same position every single time. So if you have a very delicate specimen that's kind of hard to place in there, you can kind of line it up with these, and you can use the toggles, or you can use our foot switch to close it right as you get it into place. So the proper alignment we've seen both vertically and horizontally. We've talked about the offset is kind of already taken care of by the pneumatics, just by the closing of them. But then the vertical and horizontal position of your specimen can also really have an effect on the variance of the results. So between labs, operators, you might have sites around the world that are all testing these same materials, and one of the biggest things that we've seen as possible variance is that specimen alignment that an operator is able to do. And so if you're not getting proper specimen alignment, you will see the variability and the repeatability, or variability increase, repeatability will go down. And so these can be very, very beneficial. So again, yeah, it reduces that operator dependence, it reduces the error of specimen placement. And this is, again, this is really when you're not able to automate or semi-automate some of your testing. And then the other thing that's really critical for these more delicate specimens is it avoids the need to have to open and close the faces several times. So, if you've ever had to, if you've ever been an operator, had to do some of this testing, you put your specimen in and it's not properly aligned, you open the grips, you put it back, you replace it, make sure it's good. A lot of these, smaller materials, the microelectronics like components or materials like used in batteries, they can become damaged if you start closing and opening and closing the grip several times. So maybe after the first time or two, you might actually end up getting a jaw break in your specimen just because you kept clamping it in different ways. And so this is another reason why it could be very beneficial to add these. Next slide, Theresa. Okay, and then yes, the last thing I wanted to talk about here, another thing that we've been seeing is increased demand in the electronics industry is increased accuracy for compression testing, so improved displacement accuracy. One thing we've been looking into and what we've worked on lately is being able to provide a solution that can get down to ±1 micron accuracy for compression testing in ambient conditions. We know we could already get it for tensile testing. It's a little easier because tensile testing, usually your specimens are a lot larger. But what we've seen in the electronics industry lately is a lot of these specimens, they might be, a millimeter tall, or some are in the realm of like 80 to 100 microns when you're talking about battery materials and testing. So being able to compress those and get a proper accuracy that actually is a small amount of error versus a larger amount of error is pretty critical here. And so what we've done is we've found a solution using our advanced video extensometer 2.0. It's our non-contacting optical extensometer, and we've paired that with our most accurate lens, so our 35mm focal length lens, and we do it by marking fixturing instead of the specimen itself. So obviously, if you have an 80 micron thick specimen, there's no way to mark that and track markings. So we've actually created a custom mounting and an adaptation so that we can mark either our supplied fixturing, or it can be customer supplied fixturing. So if you want to make your own fixturing, we're here to actually help guide you through that, and we can kind of help teach you what might need to be adapted on your fixturing or how you'd set that up so that you can mark your fixturing and still get the same accuracy. One of the biggest things that comes into play here is the stiffness of the fixturing itself, right? So you want to limit the amount of compliance that you're going to have, the elastic deformation that you might have in your fixturing, because that will affect the results as well. Obviously, since we're measuring from markings on the fixturing and not the specimen. So if this is an application that you're interested in applying in your lab, I think please reach out to us. I think we're happy to help and kind of guide you through that. If it's your fixturing or ours, we've done this with our own as well. And so the other thing to talk about here, the aspect of temperature testing. I know Theresa talked about how temperature testing can be very important for electronics, making sure they're okay in all environments that they're going to be introduced to. Right now, we are still able to get for the AVE2 to work in a chamber. However, you're not going to get that ±1 micron accuracy. It's going to be a little less. I would say in the realm of maybe 3 to 5 microns of error. But again, I think it really depends on testing parameters here and temperature, so it's a little harder to put a number on that. But that's another thing that we can also work with you on that if you have a need for it. And with that, Theresa, if you want to move on to the questions, yeah, all right. So we have a few questions. To start off, we have a few questions that were submitted with the registrations. So I'll go over those first, and then we can kind of get to the rest of the questions that have come in as we've been talking. The first question being, what are the best grips for testing microelectronic materials? So the most common pneumatics used for electronics would probably be our 250 Newton grips, which I showed in the pneumatic gripping slide, or our 50 Newton grips, which are a smaller version of those. Theresa, I think because this was already came in, I think if you go to the next slide, it might be shown there. Yeah, there we go. So on the left here, you can see the 2712-051, that is our 50 Newton grips. And then to the right of that is the 2712-052, that's our 250 Newton. Those are the ones that were shown in the picture before. Those are probably the most common ones. They have a wide range of jaw faces, and it can we can pretty easily make custom jaw faces that can change, depending on the size and shape of your specimen, or what else is needed, or maybe the surface that's needed for your specimen. But we have a wide range of those, so they're pretty versatile. Another option that we see a lot is our 10 Newton micro pneumatic grips. So on the right side there, those are single side action, so they're not like the dual, like the ones to the left. But those can be commonly used for a lot of microelectronics testing. They have a much smaller face, but they have high repeatability, and again, they're pneumatic, so it can be really helpful for small specimens. It's pretty easy to kind of fine tune exactly what you're going to be gripping with them. And we have a lot of other options. So if you check out, we have our electronics industry page on our website that does have several other options. And this kind of leads into one of the other questions that we got, so we kind of tied them together. And someone was asking, are we going to cover all electronics fixtures in this webinar? And unfortunately, no, we didn't have enough time to do that. Today, we really wanted to focus on our accessories that customers might not be as familiar with. But we have a full range on our website with other things such as stud pull testing, a lot of die shear testing, other tensile grips and flex fixtures and whatnot. So go take a look if you have other applications that you're curious about that we haven't gotten to. And then one other question that came in with the registrations is someone was interested in learning about the methods and equations used by Blue Hill Universal Software to calculate some of the metrics, such as automatic Young's modulus, and slope, and others. So there's a lot to unpack for this question. I think it's a little hard to go over everything in full today for here, but a couple good recommendations that can help guide you on this. One being, again, on our website, on our software page, we have a lot of videos that have been done that kind of walk you through some of these calculations and walk you through some of the software. And then a big one that will be really helpful if you're trying to understand methods and equations behind some of these calculations. One of the other application engineers that I work with at Instron, she recently did a live video on YouTube talking about our help file that's actually built into our software. This help file is extremely useful. We use it almost every day as application engineers. Basically, if you go into it, it's within the software, you can look up a certain type of calculation. So if you want to look up automatic Young's modulus, the help file will give you some details about it, and it will also tell you how it's calculated. So it'll tell you what it's looking for and what criteria it's going to use to calculate that and give you that result. And it can also help guide you on the different types of modulus. I think that was actually one of the things that she did cover in her live video. So definitely go check that out and see if that can help with most of your questions. All right, we're getting some other questions in here, so just give me a minute.
Yeah, I've been, while Charlie's been answering some of those questions, I've been able to look. So Charlie, while you're looking through the submitted questions, I'll go ahead and address one of those.
Sure.
One of the questions was concerning the XY stage and what the maximum forces are for compression and tension with the adapter plate. And so that adapter plate is rated up to 2 kilonewtons. That's the same for the stage itself. So whether you're using the manual adapter plate that gives you that type O coupling, or whether you're running an automated test on the XY stage, that stage has a maximum force of 2 kilonewtons. And so that will work on the majority of our single column systems. But of course, you would have to, if you were using this on a 5 kilonewton single column or one of our table models, then you would just want to be aware of that and make sure that you limited any testing that occurred while the XY stage was in place. Make sure that you limit that to 2 kilonewtons.
Thanks, Theresa. So one other one here is, can auto slack correction be leveraged to translate and align samples on the display graph? So I assume you're kind of referring to what we call our slack correction. So we do have slack correction, or we have, you can use a preload. If you're using slack correction, it would be after you've already got your data, and it definitely can be used to align your samples on your graph. I think there's some caveats that you have to be, you pay attention to. I think slack correction will apply to every single specimen, so it needs to be criteria that every single specimen meets, such as maybe a minimum load that they all have to meet at the start of your test, or maybe making sure you're zeroing your displacement. So there are some things there, but yes, it absolutely can be used to help align the samples on the graph. I think that's another thing. Again, the help file, extremely useful in cases like this where you can see the different ways that you can use slack correction. It can actually show you, because we have an automatic slack correction, that you can see how it's being calculated. And then you can also see, you know, other ways of using our slack correction, such as just making, you know, maybe saying start every specimen's zero displacement at 1 Newton or something like that. So there's different ways you can use it. Another question here. Let's see. How fast can an XY stage move? During testing, the XY stage moves at 25 millimeters per second, and that's to help maximize throughput. While jogging, setting up, it will move slower, but that's more for finer precision. We do have some videos on our site, so if you want to look at like a video of the testing, I think you saw it, like Theresa shared some videos today. It moves fairly quickly during testing, and then, you know, during jog, again, it's going to be a little bit slower for more precise movements.
Charlie, there's another question here about how does the measurement of voltage work and integrate with the test system. So basically, as long as you can, we can take the signal out from the device and put it through a signal conditioner. And then it's a cable that plugs into one of our transducer channels. So the same channel that you might plug a load cell or an extensometer into. And then the software, all you need to do is go in and just set up that transducer, so to speak. So for example, for the power supply, you might go in and calibrate it. So basically, when there's no button being pressed, you would expect there to be 0 volts. So you would do a coarse calibration there, and then you would press the button down and input into the software that would be associated with 10 volts. So when this button is pressed, there will be a 10 volt output, and use that to calibrate, and then that will just be in your software. And then it works like any other channel, any other transducer that you have on there, where you can plot it, you can store the data into your data file along with load and displacement. So it's really, it's just a couple, again, it's just a couple of cables, a signal conditioner, and just a couple minutes to set it up in the software.
We have one, maybe not directly electronics, but similar. What grips do you suggest for thermoplastic samples? So this one most likely depends on the material itself, but in general, I would probably recommend our pneumatic grips. Pneumatic side action are probably the easiest and most repeatable ones. I think it depends on the max load you're expecting and the size of your specimens, but we do have a range. So those 2712 series grips that I called out before, we have larger versions of them too. So if your plastic samples are going much higher, we have pneumatics up to 10 kilonewtons in those 2712 series. So that would probably be what I recommend. So another one here. Can I put the XY stage onto my 5500 frame? So the XY stage itself requires a 5900 or 6800 electronics, so the controllers and electronics inside those. So it can be used on a 5500 frame as long as the control electronics have been upgraded. So that would be either upgraded to our current 6800 platform or our previous 5900 platform. So that was just recently phased out from production, but it's still in full support. So either of those will work. Theresa, you were talking about the, you answered the thermocouple as I transduced your question, okay.
Yeah, there was one kind of related, that was kind of a related question that was also about, can Instron help set that up? And so, yeah, so we can certainly provide, the signal conditioner and the channel, as I mentioned, but also our service group can help you. So when you're thinking about the calibration process or how to include it in your test method, that's certainly something that could be covered during training or by your service engineer or a tech support call for that. Yep. And so I think we have a couple of other questions, but I want to be considerate of everyone's time. That we're closing in on 3 o'clock very quickly here. So we will go through these, Charlie and I, and for any of the questions that didn't get a response yet, we'll reach out to you with those responses. And so other than that, I'll hand it back over to Nick.
Hey, Theresa, I just want to answer this one last question.
Sure, Charlie,
it's just
go ahead.
a very simple, quick one. Can a specimen centering device be attached to any manual grips, so non-pneumatic? And the answer is, I wouldn't say any manual grips, but yes, it can be added to some of our manual grips. We have, our advanced screw side action that we do have specimen centering also available for. So yeah, you can reach out if that's something that you're interested in. But yeah. Sorry.
Okay.
And then with that, I guess we can hand it back over to Nick.
All right, perfect. Thanks, Charlie. Thanks, Theresa. Before I wrap things up, I just have a few quick notes. So we will be emailing each of you a copy of today's recording along with the slide deck. And then the only other thing I want to mention is we do have a number of other great webinars lined up in the coming weeks. So this includes an introduction to Trend Tracker for Blue Hill Central. This is a data analysis module for our latest lab management application. This is scheduled for May 18th. And then on May 26th, we'll be hosting a session on YouTube Live for slack correction versus preload. I just dropped a link into chat for that. And I know Charlie had mentioned a previous YouTube Live for the help file. If you do visit our YouTube channel, that is a video that you can still access and watch. I think it's around 20 to 30 minutes, a really in-depth look at just kind of like what that help file is, how you use it. So I think that one is a good one to check out if you have any further questions about that one. And then with that said, I just want to say thanks to Theresa and Charlie for their presentation, and a special thanks to all of you for attending. Really appreciate you joining us, and we hope to see you again at the next one.